Do you understand much about simulations?
I've read the AP Calculus book twice, so
Okay.
I know that much.
All right.
So, yeah, here, let me turn to that. Probability and simulations. I'm realizing how tough it is to actually tutor statistics. Not sure what the best way to proceed is. Do you have problems that are like the exercises at the end of the chapter?
I don't, because we get like course packs, like I don't have anything right now.
Okay, I would definitely be interested in seeing the kind of stuff they have you do for tests, homework, and quizzes.
Okay.
Because
Let's see if I can find like a previous problem that we've done as an example.
in other words, I've got the AP statistics book that she's basing it on, and it has exercises at the end of each chapter, but in all honesty, I haven't tried to do them. Just kind of waiting until a student needed me to do that.
All right. So
how to go about doing it. So help me out here.
So here's a problem. 20% of the population smokes and then A, explain how to simulate a probability of randomly selecting 5 people and selecting all smokers.
Okay. This is a probability problem.
Yeah, simulations, so you have to describe how you would.
But the question says, find the probability of finding 5 people at random that all smoke, correct? Or no. Yeah. The problem is, how would you design a simulation?
Yeah, so explain how to simulate the probability of randomly selecting 5 people and selecting all smokers.
Okay. Well, let's talk about theoretical first. Probability of any person smoking is 0.2. We know it's going to multiply, so it's really going to be 0.2 to the 5th power. That's the probability that you will run into 5 people at random that all smoke. I don't know what that number is. Maybe you can figure it out on your calculator.
Do it right here, yeah.
Yeah, take 0.2 to the 5th.
It's 0.00032.
0.000. I knew it was 32. I just wasn't sure how many zeros there were on it. It's interesting how 2 to the 5th is easy, but 0.2 to the 5th is not obvious at all, at least not to me. So that should be the theoretical probability. And now the true probability comes from determining a simulation. So the question is, how would you design a simulation? Well, the key factors in designing a simulation has to be an SRS, standard random sample, as opposed to a voluntary. In other words, you can't have a radio show and say, okay, we'll do a statistical sample here and let people call in, because that's not random. If somebody smokes, they're probably less likely to call in than if they don't smoke, so that would be heavily biased. So that'd be the number one thing. The number two thing is make sure you have a large enough population. You obviously aren't going to get super accurate results if you only interview 10 people. Although this the first 5 people that you talk to, that's the odds that they would all smoke.
Mm-hmm.
Not totally sure what they're asking for here.
I think like kind of what she's asking for is to actually like write out like what are you doing to test this? Like what is your trial? And what does success look like in the trial?
Okay.
So I think for this, like the trial is selecting 5 random people.
Okay.
So selecting 5 numbers from a random digit, and then
let's say you had a phone book of the United States. You could use one of those random number tables.
Mm-hmm.
And randomly pick numbers that might correspond with a certain letter combination. I mean, that's not the hard part, is figuring out how to pick a random number. There's any number of ways to do that, from tables to calculators to programs and apps, random number generators. So that's the easy part. But you could certainly pick out 5 random people from a phone book of the United States, call them up, ask them whether they smoke or not, and repeat that numerous times. In other words, if you really wanted to prove out this theoretical value, well, then you're not going to learn much if you only call 5 people, right? Because it's almost certainly going to fail. But let's say you did 5 people at random from the phone book, and you did that 1,000 times. Well, the odds kind of favor that in 1,000 trials you will get the first 5 people that you call that all smoke. Mm-hmm. And so that's one way I would design a simulation. I think.
By the way,
what's that?
Which, by the way, we learned something really cool in the calculator today. Yeah. You can use the calculator. It has its own random digit generator.
Cool. The Inspire?
Yeah.
I'll have to learn how to do that. Yeah.
If you go into just like a scratch pad calculator.
Let me get it out. I'm dying to get a virtual one of these. I don't suppose you have any clues on how to do that, or a recommendation of one?
I could talk to one of my teachers because I know they all, well, I know Valerio has a digital.
I used to have one for the TI-84, and it was beautiful. I could put it up on my screen and teach people how to use the TI-84. But I switched to Windows 10, and I haven't been able to find either one now. So under Scratchpad, what do I do?
So you go to, if you're just in a calculator page, go to Menu.
Okay.
And then hit Probability, and then hit Random, and then hit Integers.
Okay.
And then you'll get a little thing that says Random Integer. And so for in this case, if we're at 20%, so you do 1 to 10. So 1, and then use the comma, 10. So that's 1 to 10, and then digits. And then you can say how many digits you want as the third.
I'm still looking. Oh, there's the comma. Sorry.
Yeah.
1 to 10. So it's.
And then do another comma.
Give me a random integer between 1 and 10.
Mm-hmm. And then do another comma before you do anything. Mm-hmm. And so if you want 5 people, you put 5. So you have integers between 1 and 10, and 5 integers will pop up.
I have 1 comma 10 comma 5.
Yep.
End parentheses.
Do that.
Okay.
And 5.
And I got 10, 10, 2, 6, 5. So I would need, actually I'd probably want to do 1 to 5, wouldn't I? And if I
yeah, you could.
Yeah, if I did 1 to 5, then I would need 5 numbers that were all the same. Is that right?
Yeah.
In other
You
words,
just want, so then you would
1 to 10.
repeat it until you get all your numbers between 1 and 2.
Right. Or
You're really trying to test it.
Right. Oh, I see what you're saying. Yeah. That's what I would need in this case.
Yeah.
And in the other case, I would need all 5 of them to be, I guess, 1, not just the same, but they'd all have to be 1 if I were to go from 1 to 5, comma 5. Okay. Well,
Oh, yeah, they would all need to be 1.
Yeah, that's cool. Always nice to learn something new on this computer, which is what it is. What else? Anything else we can talk about here? You know, I noticed that the probability chapter in this book is not nearly the same as the probability chapter in some of my precalculus books. It treats it completely differently. I'm not quite sure why. In statistics, doesn't seem nearly as robust as the probability that I've encountered in non-statistics books.
Yeah.
Which is a good thing, I guess. They don't heavily get into combinations and permutations, which in other words, like how many different ways can you select a meal of 3 courses from a 10-course menu? That kind of a question. And that is a combinations question. And I think it's 10, choose 3. But the statistics book that has about 1/3 of it is probability doesn't really get into that very much. I'm not even sure it touches on it. Combinations and permutations, which definitely surprised me. Whether or not you get into it heavier than that or not, you might. Your teacher may get into probability a little deeper. Let me know. Anytime we're going to have a session and you have like some probability problems, try to send them to me in advance if they look complex at all, like the one I said. Just let me have some time to maybe try to find some examples of it. Simple probability I'm pretty good at. But
that's pretty much just what we're doing is simple probability right now.
Yeah, it seems like it. They don't, which really does surprise me. I figured a class that used to be called statistics and probability, it's probably only called statistics now, isn't it?
Oh, it's inferential probability and statistics. We just like started probability though. Like this is still like the beginning of the probability unit.
Okay. Well, I should be able to help you with that if you need it.
But I have a feeling I'm going to need the weekly sessions just starting from now because I think this is going to lead into some more complicated probability.
And not only more complicated probability, but more complicated statistics also.
Yeah.
The last half of this book is a lot harder than the first half. To the extent that the first time I read it, it was like I was reading it, but I wasn't really understanding it. And I knew that I was going to have to read it a second time to really understand it. So when we get later in this, now this is a whole year course, or is this just a 1 semester course?
This is so inferential probability and statistics is a 1 semester, which leads into AP Stats second semester.
Oh.
So I'm taking this as concurrent enrollment anyway, so I'm getting college credit for it still. So I'll be getting
Oh,
6 credits of college credit if I pass the AP exam.
okay. Well, having read the last half of this book, that's not necessarily going to be an easy task. Statistics can really get fairly complicated. Not as complicated as probability. Probability can really get complicated quickly. Not so much in everyday life problems. They're fairly straightforward, but it didn't take much to complicate it. Okay. Anything else you want to talk about? For this stuff today? You got any other problems that?
I don't think so.
Okay. Well, I'd like to volunteer some wisdom if I knew what to volunteer, but I don't at this point. I'm still kind of new to this too. So we'll have to work our way through it. You're unfortunately my guinea pig, Cole.
That's all right. I don't mind.
Okay, good. How's everything else going in school?
Everything's going pretty good.
Yeah.
I was sick a bit this week, so I'm playing catch-up game now.
You still have an SAT ahead of you or not? You done with those?
I took the SAT last year. I got a 1210 on it, so.
You gonna go with that? You're not gonna take?
Yeah, I'm gonna go.
Okay.
I'm gonna go with that. I think that's well above what I need to get into one of my schools. So.
That's a pretty good school. What'd you get on the math?
The math. Let me pull up College Board real quick. I can just pull it up real quick. Or I can just.
Exactly. I was just curious if your math was higher than your verbal or lower.
No, you're good. Just looking here. I just have it on my CSU application here. So I got a 580 on the math and a 630 on the reading and writing.
Cool. Cool. Well, good for you. Yeah, that should get you into a lot of schools.
Mm-hmm.
All right. Well, have a good rest of your week, and I'll talk to you next Thursday.
All right. Talk to you next Thursday.
All right, cool.
Bye-bye.